Alright, so these are on Google Classroom. If you want to look at them more closely. I'm going to do a couple of these with you, and then I'm going to let you do some on your own. We know how to solve this in a matrix, so we just need to work on writing them. So let's talk about Kristen. She's not here to defend herself, so let's talk about her for a minute. Okay, she spent $131 on shirts, but she did get some fancy ones. She got fancy shirts, okay, so it's justified. Fancy shirts cost $28 and plain shirts cost $15. And she bought a total of 7 shirts. Okay, so then how many of each kind did she buy? All right, so what do we have? What 2 things are we looking for? Right. So let's say F is the number of fancy shirts. And P is the number of plain shirts. So my advice, first thing, define your variables. It's much easier to figure out the answer when you know what you're actually looking for. We're looking for the number of fancy shirts purchased and the number of plain shirts purchased. Okay, so how many shirts did she get altogether?
7.
And how did she get those? Okay, $131, 7 shirts. I actually have 2 equations here. I have an equation right here, and I have an equation right here. If it's a total of 7, what operation would that be? Addition, right. Fancy shirts plus plain shirts total up to 7. Now let's talk about that money. How did we get $131 spent? $28 per fancy, $15 per plain, right? Okay, now use a matrix or set up a matrix for your coefficients, for your variables, and for your answers, and figure out how many of these fancy shirts and how many of these plain shirts that she bought. Excuse me. Are we done? How many fancy shirts did she get? 2 fancy. Which means she got 5 plain. Kristen should treat herself more. Get more fancy, less plain. Maybe she's just a plain person, though. I don't know. Alright, So what I would do is just go to a matrix, 2 by 2, and 1, 1, 28, 15. And then go back to the matrix, edit B, which is going to be, it's still a 2 by 1, but it's a 7 and 131. No, 131. And then I'm going to do matrix A's inverse times matrix B. So the inverse of A times B. And that gives me 2, 5. And my F comes first, so that's my fancy shirts. My fancy pants. Alright. Okay, so read number 2. Got some animals in a barn. We have 13 animals in the barn. Some are chickens and some are pigs, and there are 40 legs in all. How many of each animal are there? Okay, so I'm going to give you just a second to try and set that one up, and then I'll set it up with you. Okay, so what are you looking for? Alright, so I'm going to say C is the number of chickens, and P is the number of pigs, little piggies. So what does C plus P equal? Alright, and then what'd you do for your other one?
2C plus 4P.
Right, 2 legs per chicken, 4 legs per pig, gives me a total of 40 legs in all. Alright, so what'd you get? Do we know yet?
6 chickens and 7 pigs.
6 chickens and 7 pigs. 7 piggies. We're going to skip down to number 4. I know you can't see it, but I think a couple of people are still writing information from this one. So I'll move it in just a second. Alright, so a class of 195 students went on a field trip. They took 7 vehicles, some cars and some buses. Find the number of cars and the number of buses they took if each car holds 5 students and each bus holds 45 students. So I'm going to give you 1 second and then I'll, bless you, then I'll work this with you. So what are you looking for? Alright, so C can be the number of cars, B, the number of buses. This is called defining your variables. Okay, make sure you do that. You always need to define your variables. Okay, so what are my equations then?
C plus B equals 7. 5C plus 45B equals 45.
Okay, so how many cars and how many buses?
3 cars, 4 buses.
Alright, very good. Very good. Okay, so there are more questions on the second page. There's 5 more questions. I want you to do these 5 questions, but I also, before I turn this off, so everyone can hear, including the people, our viewing audience at home, you have a quiz tomorrow on matrices, just stuff that you can do to a matrix. You can add it, you can subtract it, you can multiply it, you can do scalar multiplication, you can find a determinant, you can find an inverse, all that stuff, and using a matrix to solve a system of equations. Okay? That's tomorrow. No, it's all just matrices. Yeah, well, they take too long. I mean, seriously, they take, if that you could have that one problem, and that would be it. So, but have a calculator tomorrow. Somebody tell that kid who's not here to have a calculator tomorrow, because it's going to be bad news if you don't. So have a calculator. If you don't have a calculator, borrow one.
Is it on Classroom? I don't see it.
It's not on Classroom?
No, I said yesterday.
Okay, I'll just, if it's not, I may. Sometimes I think I post stuff.